Hello, students. This is Dr. DA, and I'm going to try to help you here with the experiment you just did, where you synthesized a coordination compound, and now you are asked to analyze for its percent copper and for the ratio of ammonia to copper in the compound. So let's go ahead and start with the first one here. Let me do some manipulations here for a moment, please. Excuse me. Okay, so this is the procedures set that you just did, and I'm going to show you a few items. First of all, take note that the compound you synthesized, tetraammine copper 2 sulfate monohydrate, has a molar mass or molecular weight of 245.80 grams per mole. And over here, we have given you a couple of examples of how do you calculate the percent of copper in a compound. So that may be one of the first things that we'll do. Remember that you did a titration using sodium thiosulfate. The main thing about that titration is to be reminded that the ratio is 1 unit of thiosulfate per unit of copper 2 ions. That's going to be the stoichiometry of a reaction. And if you want, please review the procedures. Let's look at a sample data set that I have in here. And sorry, I don't have a name this time because I forgot where I got this from. So here is a sample data set where you have the grams of compound, you have the molarity of sodium thiosulfate, which is probably not the same as the one you did. This is the simple titration. We use 12.75 milliliters in order to titrate that amount of copper. So we're going to do several calculations here. I'm going to go ahead here and put some numbers here. Sometimes it helps. 1, 2, and I'm going to put this as 3. And then we're going to number these here: 4, 5, 6, 7, and 8. And notice that I skipped these 2 here. If you want, we can call these guys 3A and 3B if you want, in case you didn't start at 0.00 milliliters. But the important thing is, what was the actual final volume? So let's do a few calculations here. First of all, we're going to calculate the number of moles used. And I usually suggest, don't try to cram your calculations in here. Just take a separate piece of paper, and let's call this simply calculations. And the first we're going to calculate here is the moles of thiosulfate that we employed in this. So essentially what we have here is, let me see if I can move this around so we can see everything in place. There you go. So we had 12.75 milliliters of thiosulfate, and our solution had 0.1095 moles. You can see that here, number 2. And this is per liter, but we're going to go ahead and make that 1,000 milliliters. That's a liter. And that way we can do a straight calculation here. Okay, let me give you a chance to maybe pause and maybe check this over again. Make sure you understand what we're saying. I apologize for this blurb in here. This was item number 2. And of course, this was item number 3 here in our data sheet. Okay, so let's see what that is. Simply said, we're going to calculate this here. So that is 12.75 times 0.1095 divided by 1,000. And we get 1.396125 times 10 to the minus 3. We only have 4 sig figs available here. So let's round that to 1.396 times 10 to the minus 3 moles. Now, personally, what I'm going to do right now is I'm going to put that in my memory, in my calculator. I'm going to let my memory retain that, which means that at the end, rounding and stuff might get a little tricky, but that's okay. Okay, item number 4 is the number of moles of copper in the sulfate. I'm sorry, number of moles of copper in our compound. Remember that our main thing here was that there should have been, let me go back to the procedures here. Remember we said that there is a ratio of 1 mole of thiosulfate reacted for 1 mole of copper 2 ions in our sample. So that means that when we do that here, we probably don't need to do the calculation, but basically moles of copper 2 equals moles of thiosulfate used. I'm sorry, my pencil's not sliding very well. And this is a same as we got in item number 4. So I'm going to go up here and I'm going to just put that in here. Let's go ahead and write these numbers here on the data sheet. So item number 4, 1.396 times 10 to the minus 3 moles. And we said that it is the same amount for the number of moles of copper in the sample. So now we need to find out how many grams of copper do we have in the sample. Okay, so what we're going to need now is we're going to need our periodic table, of course. So this will be item number 6, grams of copper. Of course, that should be item number 4, which is the number of moles times the number of grams per mole of copper. Now, you might not have your periodic table with you, but I let you know that over here on the first page, we had actually done that already. 63.55 grams per mole. Let's go back here and say we have 1.396 times 10 to the minus 3 moles. And we have 63.55 grams of copper in 1 mole. And I had kept this in my memory here, so I'm going to go ahead and leave it in there. So this times 63.55 equals 0.08872. Now there's several other numbers in there, but remember that we only have 4 sig fig digits available here to us. So we're going to leave it at that. And that's the number of grams of copper. This is item number 6. Let's go back to our data sheet and let's write that down here. 0.00872 grams of copper. And now we're going to find what is the percent of copper in the compound. So again, we're going to use the same modality here. What is the percent of copper? So we have the grams of copper here, item number 6. We're going to divide that by the grams of compound that we had, which was item number 1. And we're going to multiply that times 100. All right, so let's go ahead and do that. So we have 0.00872 grams of copper divided by the total sample, which was 0.3257. 0.3257 grams of compound times 100%. And what I'm going to do is I have this number here already. I'm just going to divide it right there by 0.3257 times 100. And that gives me 27.2409. But remember that we only have space for 4 sig figs in here. So that'll be 27.24% copper. Let's write that down in our data sheet. 27.24% of copper. Now for our last one, we're going to calculate the percent error. To do that, we would have had to do a little homework first. In the same mode that we, in the same mode that we calculated earlier on the percent of copper in these 2 sample compounds, we're going to have to calculate the percent of copper in our compound here. What is the real amount? Okay, so what I'm going to do is I'm going to come back here to our data sheet, and let's do, before we do item number 8, let's do some homework and say that, remember that we're going to copy this mode here. We're going to have 1 mole of copper in every mole of our compound. We were just told that 1 mole, sorry that this will turn around, of our compound is 245.80 grams of compound. Okay, we're going to cancel that out. And then remember that we know that there are 63.55 grams of copper in 1 mole of copper. That cancels that one out. So we're going to be left with the grams of copper divided by the grams of compound times 100%. So let's see what that gets us, okay? So let's say that we have, again, 63.55 divided by 245.8 times 100 equals 25.85% copper in the compound. Now, to find number 8, which is the percent error, we use the standard formula, which is the absolute value of the, we can do it in any order because we have the absolute value here. So we're going to take out what is our experimental value minus the real value divided by the real value times 100%. So in our case, remember our experimental value is this value here we had in number 7. So that's going to be 27.24 minus the real value, which is 25.85, divided by the real value, 25.85. And just to avoid negatives, just in case, we're going to take just the absolute value of that times 100%. So let's go ahead and do that calculation right here. So we had 27.24. We subtract the real value, 25.85. We divide that by the real value, 25.85. And we multiply that times 100. And we get an error of 5.377%. This number here, I don't know if you recall, was only good to about 3 sig figs. So we're going to say that this number here is going to be 5.38%. And that is the value we're going to bring back to our data sheet. And there we go. This is now 5.38%. Again, feel free to go back and pause at different times in the video. Let me go ahead over here. I'm going to switch over here. And hopefully that helped. And if you have any other questions, please feel free to send me a message or ask me at our session this week. Thank you so much.